In this module, we discuss sterilization and aseptic processing. To be able to understand the subject a little better, it might help if we familiarize ourselves with certain very peculiar microbiological issues. As a chemist, if you were to take 1 mole of sodium and 1 mole of chloride, you always get 1 mole of sodium chloride. This was so yesterday, this is so today, it will be so tomorrow. But for a microbiologist, things are not so certain. He gets yields for 1 day, 2 days, 3 days, and suddenly for no reason he gets no yield or much less yield. Conditions have not changed. In fact, for microbiologists, variability is the name of the game, is the way of life. They have exotic yield and find absolutely no exotoxins. On another day, they have very sparse yield but abundant exotoxins. So it's very difficult for them to talk about consistency in the same sense as synthetic chemistry. Yet another peculiarity is that for the average chemist, 20% nitric acid and 80% nitric acid, there is considerable difference. 10% sodium hydroxide and 90% sodium hydroxide, there is considerable difference. But for the microbiologist, if he finds 3 colony forming units, it doesn't particularly mean much to him because he knows that in an hour it might double, it might even treble. And therefore 2 or 3 or 4 or 5 doesn't make too much of a difference for him. For him, a figure is deemed significant if the difference is an order of magnitude. So you find most of them speaking about 10 raised to 3, 10 raised to 4, 10 raised to 5, 10 raised to 6 colony forming units. But you seldom see them saying 3 colony forming units as distinct from or different from 7 colony forming units. Now because it is 10 raised to 6 and 10 raised to 5 and so on and so forth, and it is an exponential distribution, a simple mathematical transformation in terms of converting these figures into logarithmic figures, log to the base 10, gives them values 10 raised to 6, 10 raised to 5, 10 raised to 4 becomes 6, 5 and 4, and therefore is more linear.